Since the genesis of human history, civilizations have grappled with the relentless onslaught of diseases. Plagues and epidemics, like ominous specters, have cast shadows upon the once majestic grandeur of mighty civilizations, orchestrating the downfall of some of the most powerful societies of all time. Life as we know it would not be the same without penicillin, the antibiotic that is directly responsible for saving the lives of hundreds of millions and revolutionizing the world we live in today.
The concept of a miracle drug like antibiotics, you know, it was a bit like the atomic bomb, you know, we wouldn't have dreamed of that.
The concept of antibacterial compounds predates the discovery of penicillin. The first of its kind was salvarsan, an arsenic-based compound developed by Paul Ehrlich in 1909. Salvarsan, also known as arsphenamine, was specifically designed to treat syphilis, a common and debilitating STI at the time, attracting the attention of many onlookers around the world. This proclaimed magic bullet, however, was extremely difficult to administer due to its unstable and toxic nature, and had side effects including rashes, liver damage, and risks of life and limb, literally. While the use of salvarsan was largely limited, its discovery influenced the curiosities of many researchers and scientists alike, igniting the search for more agents that could replicate the effects of the arsphenamine. Among these researchers was Alexander Fleming, professor of bacteriology at St. Mary's Hospital in London. In August of 1929, Fleming had been investigating the effects of the infectious staphylococcus. After tidying up his laboratory, he placed the petri dishes he had been experimenting on in a bath of antiseptics. As it turns out, he did not have enough to fully cleanse all of the equipment, and a couple dishes remained littered with bacteria and microorganisms. During that summer, in which he went on his annual trip to the Gulf of Scotland, a couple specks of mold would blow into the window of Fleming's laboratory into the sink. The mold, Penicillium, had inadvertently contaminated a petri dish. Upon returning, Sir Alexander Fleming was greeted by an intriguing sight. In the petri dish where the Penicillium mold had taken root, he noticed that the growth of the bacteria seemed to be mysteriously inhibited. He identified that the mold produced a self-defense chemical that could kill bacteria, and later named this chemical penicillin after the mold. Unfortunately, Fleming was only able to do trials of this antibiotic on small samples of bacteria, failing when it came to larger, more densely concentrated colonies due to a shortage of the mold. Thus, he was forced to abandon the project and penicillium was forgotten.
Fast forward to the tumultuous years of World War II. The chaos of the warfare was a breeding ground for bacterial infections, where wounds festered and diseases ran rampant. A single bullet wound or injury could transform a battlefield into a fight not just against the enemy, but against the specter of death itself. If left untreated, an infection could spread like wildfire around the body, often leading to the amputation of limbs. At the time, the most commonly used antibiotic was sulfa, a compound derived in years prior to the war that was used to treat various kinds of infections and battle wounds. However, a study performed by a collaboration of hospitals found that there was little decrease in the rate of infection on burn wounds against sulfa, further supporting that these drugs could not defend against invasive species that were deep into the wounds or already in the bloodstream. It seemed like every drug developed had the potential to harm as much as it healed. As war broke out, it became vital that those on the front lines received superior treatments than anything previously available. Little known to the world, a new drug had slowly been developing in the shadows. In 1938, Ernst, a researcher at Oxford University, discovered Fleming's paper on penicillium. He then suggested to his boss, Howard Florey, that he attempt to isolate the compound to further investigate its properties. The following year, Howard Florey put together a team that included Chain, who successfully refined penicillin from an extract of the mold, Norman Heatley, a specialist in fungi who worked on cultivating penicillium in huge quantities, and Florey, who was in charge of live animal trials. On May 25, 1939, the team tested their newly made penicillin on 8 rats who were given a strain of the viral Streptococcus. In the morning following their procedure, the team observed that the 4 mice who were given penicillin had all survived, while the ones who did not were found dead. Chang deemed this outcome a miracle.
Unlike sulfa, penicillin was a liquid that could be injected intravenously, allowing it to spread around the body. Moreover, penicillin was much less toxic in comparison to its predecessors and yielded much fewer side effects. Even with this success, however, production needed to increase 1,000-fold if it were ever to be used on the front lines. Florey and his team took their insights across the seas to the Northern Regional Research Laboratory located in Peoria, Illinois. The NRRL leveraged its expertise in agricultural fermentation and mycology under Robert Coghill to lead the penicillin project to an even greater height. The NRRL scientists focus on pragmatic solutions, refining the mold, optimizing the growth medium, and transitioning from flask-based surface culture techniques to large-scale, tank-based fermentation. The War Production Board worked with a total of 21 US companies that joined together, working vigorously to circulate the newest information amongst its participants, creating a global collaborative amongst allied countries. As Albert Elders said, the coordinator of the penicillin project, attaining maximum production today depends on the efficient harnessing of the know-how recently developed. As of late 1942, penicillin production was modest, catering to fewer than 100 patients. Less than 2 years later, a remarkable transformation had occurred. The penicillin supply surged exponentially, poised to meet the escalating demands of the Allied forces, pushing out 2.3 million doses of penicillin in preparation for the D-Day invasion of Normandy. Penicillin quickly became known as the war's miracle drug, curing infectious disease and saving millions of lives. After World War II, the development of penicillin continued with a focus on refining its production processes, enhancing effectiveness, and expanding its applications. Examples including the NRRL's experiments with calcium carbonate, corn steep liquor, lactose, and nutrients to increase production yields. Scientists further engaged in systematic modifications to the penicillin molecule, leading to the development of semi-synthetic and synthetic derivatives with improved stability and broader spectrum of microscopic activity against various bacterial strains. Concurrently, pharmaceutical companies invested in research and development, scaling up production and streamlining manufacturing techniques, leading to the commercial availability of different formulations and types of penicillin, such as penicillin V and penicillin G. The relentless pursuit of innovation and the collaborative effects of researchers, pharmaceutical companies, and regulatory bodies have propelled penicillin's uses in the world we live in today. Penicillin and later antibiotics have saved countless lives by effectively treating deadly bacterial infections. By lowering the chance of infection after surgeries, penicillin not only caused more successful surgeries, but allowed for the development of more complex ones, such as organ transplants. Without penicillin, cancer treatments such as chemotherapy can lead to weakened immune system, which can cause more problems down the line for the patient. Additionally, antibiotics have been vital in fighting infectious diseases, greatly helping to control epidemics and improving global public health.
You may not feel that any specific vaccine or medicine has allowed you to be here. But if you went back only 1 generation or 2 generations, you might be surprised how few of you would be in this audience.
Less than a century ago, bacterial infections and diseases such as pneumonia, syphilis, gonorrhea, and scarlet fever resulted in millions of deaths worldwide each year, and the world knew of no cure. In just over 100 years, antibiotics have drastically changed modern medicine and extended the average human lifespan by 23 years. Penicillin not only saved lives, but heralded a new era of medical possibilities.